a separation of concerns here. Technically, we can therefore use any tool that handles then the testing task or the evaluation task, because nothing is hard-coded anymore here. Okay, so this is what I wanted to highlight. Now, my app that I have is this beautiful app here. It's a multi-service travel application that I often use as a demo app. And this app runs on an EC2 machine. It's 4 Docker containers, and all of them are monitored, in my case, with Dynatrace. That means what you see here is my monitoring solution. I have my service here, the process. This is the host. This is my, as I mentioned earlier, this is my EC2 Linux machine, and I have enabled monitoring on that host, and therefore I see all of the different containers, processes, and Dynatrace is monitoring all of this. Now, last thing that I also have a dashboard built, because normally as a performance engineer, at the end of a test or while the test is running, I want to look at data. I want to look at how is my data doing, right? What's my response time, my failure rate? And so what I've been basically doing here, I've built a dashboard that contains all the metrics that I would normally analyze. This is just 3, but you can go crazy on it. Now, what I want is, I want Captain now to execute a test, and afterwards analyzing basically all the data that I put here on the dashboard, comparing it against what my objectives are, and then tell me, is it good or no good? And this is exactly what I'm doing now. Now, how can I kick off Captain? I can do it either through the API. So we have an API, just a regular REST API, where you can interact with Captain. This is a great way for you to integrate this with your CI, with your existing automation tool. For instance, if you have Jenkins and you're building something with Jenkins, then you can trigger Captain by sending so-called events. So Captain itself is event-driven, so you would send Captain an event to say, hey, I want you to launch and execute this automation workflow. So I could do it through here, or I decided to do it through the CLI. So I've written a very little shell script here. And basically what I'm saying, this is just doing nothing else than sending an event via the API. It's called trigger performance testing. I basically say, hey, Captain, for this Captain project, for this stage, for this application, I want to run a performance test against this URL. And then I can add additional metadata, for instance, the build number or whatever else I want. So as I'm triggering this, what Captain is doing, if I go back over to my demo performance project, here under services, I could have any application that you want to test. You would basically model it, or you would tell Captain, I have a certain service. In my case, it's Easy Travel. Remember, this is the app here. So this is the app that I'm testing. So it could be a complete app. It could be individual microservices. I decided to use the whole app. And what Captain is now doing, it is actually running my execution sequences. So I've just triggered this at 17:57. That's my local time here in Central Europe. And right now it's processing, but I can click on few sequences. And now what I see here in the sequences is the individual tasks that Captain is now executing for me. So what it's doing, remember, if I go back to my shipyard file, it is executing the first task in the testing sequence, which is finding a test tool that can execute a performance test. And that's what Captain is currently doing. It was sending out an event that says, hey, I want a tool that can run a test against this URL. That tool that you have enabled and is listening for Captain events will then pick it up. In my case, it's JMeter. JMeter has reported, hey, I've just started running the tests. Once JMeter is done, it reports back once the tests are done with some preliminary test results from JMeter, and then Captain will go into the next stage. This is what Captain will do. And once it's done, I already do a little bit of a spoiler here before I let this finish. Once it's done, it will give me an overview of all the metrics it has analyzed. And it will also come up with a total score that tells me, hey, your metrics, your SLOs have achieved 91 out of 100 potential maximum points. Here are all the individual metrics that we pulled out from your monitoring tool, compared it against your objective, and then we are normalizing everything against to 100 points, and so you'll get a nice score. All right, so I will let this run because the test runs about 10 minutes and then it does the evaluation. While this is running, let me quickly go back and explain to you, why did we build Captain and why can't not everybody just do this yourself? Because we have a lot of powerful automation tools. The reason why we built this is because we have seen that a lot of organizations are building a lot of tasks in their pipelines to automate certain tasks, especially DevOps engineers, SRE engineers. And these are just a handful of those. Now, from a performance engineering perspective, I highlighted a couple that I think we as performance engineers are trying to automate into our pipelines. Performance test execution, API tests, functional tests, chaos engineering, configuring the monitoring, like we've seen from the previous presenter, that Prometheus is delivering all the values, analyzing the data through quality gates, notifying somebody via chat when tests are done. So these are typically things we try to build into our processes using the tools that we have available, and that's all great. However, and this is now where I want to bring in two quick examples. Christian from ERT, he has been building exactly, or trying to build all of his capabilities into their pipelines. However, he soon realized that his pipeline code, now his automation code that is kicking off the test, collecting the test results, analyzing it, all of a sudden became more complex and longer than sometimes the microservices or the code that he's testing. So kind of that escalated pretty quickly, that this code becomes more complex. Another example, this is one of my colleagues, Dita. He's responsible also for our pipelining, and he has been helping our organization when we moved from a monolithic architecture to more smaller services, to then build individual pipelines to actually build, test, and analyze these individual services. And unfortunately, what happened is what happens with many organizations. You build your code for the first service that works well, then you take it to the next service, you just add maybe a different testing tool here, maybe a little configuration change here, and then you copy and paste and make some slight modifications until you end up with many different permutations, and it's very hard to figure out who actually, what are these things actually doing. We actually did an analysis, and we now know that a lot of our Jenkins, our pipelines here are Jenkins based, we have high level of code duplication in our pipelines. This is all glue code, a process that kicks off specific hard-coded tools. They parse a certain result that they know this tool produces, and then they go to the next step or not. And there's a lot of code duplication, so it's very hard to maintain all of this. And this is exactly what we wanted to address and what we try to address with Captain. We know what things people need to automate, and therefore we took this complexity out of calling a tool, waiting for the result, then getting all the results, parsing it, calculating quality gates. We took all of this and baked it into a control plane that we call Captain. So Captain is a control plane that uses a declarative approach where you can say, what type of process do you want to execute? And then you can have different tools that can then participate in the process. So we have a clear separation between process and tools. All the config files for the individual tools, as you saw earlier, are stored in Git. Everything is based on SLOs. That means every time Captain executes an action, you can always add in the evaluation step, so that always before you go on to the next step, you can say, is my system healthy, yes or no? We have seen that we can reduce automation code by 90%, which makes it much more easier. And it connects with all of your tools. So what this does for you, it helps you level up, I think, your automation. If you are trying to build performance test automation into your systems, into your pipelines, then what I've seen is that many obviously use the great reporting capabilities of your testing tools, of your monitoring tools. You put stuff in, you use Grafana or whatever you use to build nice dashboards. But if you don't have a way to then automatically analyze it, then it still slows it down with analysis. And this is what we have what we're addressing with Captain as well. So with Captain, we are standardizing on SLIs and SLOs. We can pull out data from any type of data source through a standard, which makes it easy for us to then also compare data and come up with a good evaluation. We have a kind of nice UI, I would say, which makes it easy, the heat map and so on, and everything is really, you know, based on standard. It's all open source here. Captain at the core is built on SRE practices. So I just want to quickly walk over, because I know I don't want to use all of the time, because I want to keep time for questions. When you use Captain, and especially now this is interesting for performance engineering, you specify what type of metrics, we call them SLI, service level indicators, are you interested in. You can either specify queries against your PromQL, your Prometheus, or your APM tool, or against your testing tool. You basically say, what type of metrics, SLI, service level indicators, do I want to extract? Then you specify SLOs, meaning what type of objectives do you have? These are your thresholds. So you can say, when I run my test, and at the end of a test, you're pulling out this data, I want you to compare the data with my objectives. Certain response time, certain throughput, certain error rate. Now, the thing is, we are not only allowing static thresholds here, you can also work with relative values. You see here, for the login response time, here I'm basically saying the test step for the response time for login has to be faster than 150 milliseconds, and it should be smaller than 10% plus the previous build. So I'm basically validating that there's no regression coming in by comparing it with the baseline from the previous builds. So you specify this, and then you also specify what your overall objective is. We're evaluating every SLI and SLO, and then we are figuring out how many points you have. We always normalize it to 100. And so if you use Captain to analyze your individual builds, you run your tests, then Captain will reach out to your data source, pull in the metric, compare it, and then always does a green, red, or yellow. And then with this, calculate how many percentages points you have, right? And these are just an example. If build number 2 is slow on response time and a higher failure rate, and you achieve lower points, well, then that's obviously going to then go into a warning. Maybe the developers then come in and say, hey, we fix it. Here's a new build. And then maybe this new build now all of a sudden has the first 2 things fixed, but then they cause another regression in terms of number of database calls here. And then maybe this leads to a real error, and so on and so forth. So the idea is that you constantly get feedback fully automatically. Every time you have a new build, you can say, Captain, run my test, give me my data. I just want all this fully automated. Now, what's great, I think, for you is that you can pull in data from any data source. While I'm using Dynatrace or Prometheus, you can pull in any data source. You specify for every data source, or for your data source, how to query the data. That's always the query language. So how do I get my SLIs out? And then the SLOs itself, they are tool independent. So this is where you specify, like what you saw earlier in this kind of table format, what's your criteria for every metric. And then Captain, basically, when Captain is asked, please, you know, analyze my SLI and SLO, Captain is then reaching out to these tools. It is actually sending an event. Captain is communicating with these tools through events. He's sending an event saying, I need this data from you for this time frame. Please give me the data. The data comes back. Then Captain is evaluating the data against the objective, is giving a point or giving points for every metric, and then calculates a total score. Right? And this is then how you can easily integrate this into any type of tooling you have, because we don't want to replace tools. We just want to make it easier for you to also get things like performance engineering, automated performance testing, and analysis into your pipeline. So here on the left is an example where, let's say from Jenkins, you can ask Captain, please first do my monitoring configuration, that's Monaco, then do the deployment, then run the test, then do the evaluation, and then also give me a manual approval what I want to do next. So the sky is the limit. You can start small with just the quality gates, just with the SLOs. You can do testing and evaluation. You can do also deployment. You can do whatever you want. Now, who is using Captain? I really feel proud that we got a nice feedback from Tarash. He's a software engineer at Facebook, and he hosted me recently at one of his performance conferences. And when he saw Captain, he said, Captain looks like the reference implementation of the site reliability engineering workbook. So I think that's great. Great testimonial. We also have in Captain user groups. So we are an open source project. We are running user groups every other week, and we're always inviting people to talk about how they are using Captain. For instance, Sumit at Intuit, he's been using Captain for quality gate evaluation in combination with Argo, Gatling, and Jenkins. Roman is using it in combination with Azure DevOps, Neoload, and Jenkins, where they now are able to run many more performance tests against critical financial applications. And then Christian from ERT, they are using Captain in combination with GitLab, where Captain takes care of deployment, functional test, load testing, and all of that. So to sum it up, Captain, we really try to solve the automation challenge for you. So instead of you having to build automation, you can pick a use case that you want to automate, like SLOs, like SRE automation, which is basically the performance automation, performance test execution and evaluation. You then bring your configuration, bring your configs, your test files. You remember the shipyard where that describes the process. Then you connect your tools. Captain itself doesn't do testing. It doesn't do deployment. It calls your tools through events. The magic behind the scenes is Captain takes away the pain of you having to write all of this hard-coded automation code. So it automates the configuration, and it provides these use cases as a self-service. Everything is event-driven. Everything is Git-based, SLO-based. And if you want to get started, this is a great way, I think, to get started. Tutorials.captain.sh. And last slide, there's a commonly asked questions. Hopefully there's some more now. Like, where does Captain run? It runs on Kubernetes. But what if you don't have Kubernetes? Well, then we have a project called Captain in a Box, or Captain on K3S. The only thing you need there is a Linux machine, and we install a lightweight Kubernetes cluster for you. Can you extend Captain? Yes. Captain connects to all of these services through an event bus. So you can write your own event subscriber. We call this a Captain service. And yes, Captain can also execute tests in remote systems, because while Captain itself, the control plane, runs on one environment, it can talk to other remote systems, and we call them the execution plane. And yes, with this, Alex, I think I have used pretty much all of my time, and I hope there's some questions. And just to validate, my test is now finished, which means it brought in all the metrics, it compared them, and also my second build was achieved 91 points here. There we go. So hopefully this helped to understand what Captain is all about, and how we hope we can help you with performance as a self-service. Any questions?
Thank you. Any question? I think we have at least time for one question, and then we'll move to panel, and Andy will be on the panel too, so we can answer other questions as part of the panel. So any questions?
Hi, Andy, nice talk, thank you. So I was curious, one of the issues we have with such pipelines is when the tools we use update, we have to go through all the scripts and update and update and update. So, so I was wondering, how much do you have to do that with Captain? And I don't mean externally as a Captain user, but you as the Captain developers. So do you, does it take a lot of effort to track the development of all the tools you can connect to and maintain Captain compatible?
Yeah. So very good question. I think this is also one of the problems we try to solve. So Captain is an event-driven system. So that means Captain sends events and say, hey, I need somebody to run a test, and it sends a test event. So if you remember earlier, I had in the, we call this the Captain's Bridge, this test event where JMeter responded with started. Essentially, Captain sends out an event like this. It is a so-called cloud native event, and it says, hey, test triggered. And there is some additional information about what type of test should be executed, the URL that I pasted in, and then you can subscribe your tool as a listener to these events. That means in my case, if I go to my Captain installation, I, for instance, have a so-called JMeter service, which is nothing else than a listener. And this is then taking the event that it's interested in and is then passing it on. If I would, for instance, update JMeter from version X to version Y, the only thing I need to do is I need to update this service once centrally. And from that point on, that service will receive still the same event, and it will then just use the latest tool out there, right? Or I have Argo here. I can call Argo. When Argo updates, then the only thing I need to do is I need to update this Argo service here. And all these services, so they are just containers that run and they are just listening. They can either run on the same Kubernetes cluster where I have Captain Core, the control plane, but I can also have them remote, because I remember maybe you have maybe your load generator needs to sit somewhere else. Therefore, you can also install that let's say JMeter service somewhere remotely, and it's basically listening for the events here in the where is it? API. It's basically querying it through the API service. It's pulling in all the events. Internally, we're using Nuts. Nuts is it the event-driven bus that we're using? Yeah. And the other thing maybe that I wanted to highlight is Captain Sandbox. So we have different repositories where all of our services are maintained, right? You see here Artillery, Snook, Akamas, OneChart, AWS. So this is where our community keeps updating also our services. And then you just decide which service you want to install, and then this service is then taking care of the execution.
Okay, got it. Thanks a lot. That looks very nice.
Thank you. So I guess now it's going back to Peter, who will moderate the panel.